Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen. This is Retro Ernest of Retro Electrotech. And here on the bench we have a Kenwood model KR-9400, which was produced, between about 1975 and 1976. It comes stepping into the ring at 120 watts per channel into 8 ohms to rattle your old bones. And other than that, it's a pretty good heavy bruiser, I think around 45 pounds or thereabouts. So anyways, enough of that, let's get into the meat of the matter as to why this is sitting here on my bench. So it was brought in because it was making, or is making, scary noises according to the customer, popping and crackling on one channel, the right channel. Now, one thing I want to mention about that is the customer also brought in a pair of Yamaha speakers. I forget what model they are now. I'll eventually have them on the bench because I need to evaluate some connection issues that they are believed to have. So the customer told me that sometimes when they're listening to the unit that the speakers will start acting up, or at least they believe they are the speakers that are acting up. And it sounds like they are, that there is an issue with the connections because they sometimes will stomp on their wood floor and to kind of vibrate the floor a little bit, and the speakers will sometimes come back, signal will return, and then it's kind of an intermittent situation, and in other words, thumping on the floor seems to have an influence on that. So that could also be the culprit as to why there's that crackle and pop noise going on. Of course, some connection issues involving the speakers. The speakers have had work done to them before, from what I understand. So has this receiver. They've been in a shop. Of course, I'm not going to mention what shop that is. I'm not, that's not my place. But anyways, I do know that the power switch there is reversed. Off is on is off, and that's just a matter of flipping that around. So I don't know how that came about, so whatever. But I'll get to that when the time comes. Otherwise, what I'm going to get started with is just popping the hood so I can take a look down the hatch and see what's going on the top side. Same thing with the bottom side. I want to check into the belly of the beast and make sure that there isn't any visible problems, any red flag indicators. And that's just a quick cursory inspection. So I will reposition the camera, we'll take a look inside, and then after that comes the safe power up, which I will talk about. Okay, so here we are, obviously looking down into the top side. Now, just right off the bat, I don't see anything that makes me concerned. Again, I'm just doing a quick cursory, so yeah, I don't see anything, any bulging caps. Here's our main filters here. Obviously our power transformer, our amp channels. I don't see anything unusual as far as, again, bulging capacitors anywhere. Here's our tuner section, and yeah, just right off the bat I don't see any components that look heat stressed, discolored, charred, anything that's cracked. From what I can see, this is just a quick down and dirty cursory search. Everything else looks pretty good. The wiring that I could see looks to be intact and nothing alarming. So let me go ahead and flip it over and take a look into the belly of the beast. The belly obviously is typically cleaner because, well, the dust and crap settles through the vents on the top side. Usually the bottom is a bit more cleaner. So let's go ahead and take a look. Okay, so here we are looking into the underbelly, and just right off the bat, everything seems to look okay overall. I'll just do a quick down and up scan. There's nothing alarming going on. Okay, so there are a few solder joints that are on the ugly side that need to be touched up, reflowed, all that stuff. There's some around these posts here Okay, there's one here that looks pretty shabby that has a ring around it as though it's kind of cracking around the base a little bit. It's probably intact, but to stave off any potential connection issues, any solder joints that don't meet standards, that look substandard, need to be reflowed. That's a real good idea. I'll do as much of that as I can with the time and the budget I have to work with. It depends on what I find and how far I'm going to need to go with the primary problem, which is my main objective in solving. And I can't concentrate my efforts all over the place because, you know, time and budget and all that jazz. Whatever's in my path that I can access as I'm going in, and especially if I end up servicing the controls in depth and I pull the face off, remove the boards, and start going deep there, which would probably be recommended. And this unit was serviced before, but I don't know to what extent the tech or techs went into servicing the controls. I like to do a very thorough multi-flush cleaning. I talk about that all the time, and really loosen up any debris, any dust debris that's worked its way in over the decades. Really loosen it up, flush it out multiple times, reintroduce the appropriate lubricant in the appropriate amount, not too much. Just a few drops here and there. Exercise the controls over and over and over again, and assure that I remove from the equation any issues with intermittent or otherwise dirty controls, things like that. Yeah, touch up the solder joints while I'm at it. If I pull the boards out, I'll look at, I have access to these boards here on the underside anyways. So I'll do the best I can to go through and touch up any solder joints that look ugly, and like I said, there definitely is some. Okay, so I have the unit ready to power up on the current limiter / dim bulb tester. Let me go ahead and zoom in on that. Alright, so this funky box here that you're looking at with 3 light bulbs and 3 switches on the side, the main switch here and the receptacle, is referred to as a current limiter or dim bulb tester. And I'm going to explain why that is. So you can also see I have plugged into it the stereo receiver down here, or what we refer to in geek speak as the device under test, or DUT. The reason why we want to limit the current via this current limiter, you see how those correlate? Well, the reason why we want to do that is because in order for a unit to fail in a really bad way, catastrophically, so to speak, if you want to get dramatic, it needs fuel to do that. I use the analogy often when I explain this of a forest fire. A fire needs fuel to burn. If it only has a little bit of fuel, a limited amount of air, oxygen, wind, whatever, then it's not going to be able to build into a catastrophic forest fire. Okay, if it just has a little tiny bit of brush to burn, it's going to burn out fast, and the flames are going to be pretty small to begin with. All right, so starve a fire, it doesn't become big at all, and it peters out pretty quick. Starve a device under test of current by limiting it, then it's not going to have the fuel that it needs to go into a catastrophic failure, or at least that's the intent. Again, when something is going to short out, let's say that there's some components in here that are teetering on the brink of shorting out badly, like the main filter capacitors and something like that. By limiting the current when I power it on, I'm decreasing the risk of it sustaining further damage or going into a big, a big failure and making big, horrible, scary noises and things going pop, bang, smoke coming out, and dogs in the neighborhood scattering in all directions, cats running up the trees, little screaming kids in poopy diapers running around in circles and all that stuff. So you don't want to be a menace to the neighborhood. So that's what I'm getting at here, is we want to limit the current. And how is that done? Well, the 3 switches on the side here bring in the different bulbs that you see. So I could bring them in one by one or in combination or whatever. And it's the bulb filaments that act as resistive elements. And resistive elements will, of course, in turn limit the current flow. So based on the size of the resistive element, its resistance, size and resistance, will dictate how much current is allowed to be consumed by the device under test here. So the smaller bulb in terms of wattage, and it happens to be physically smaller as well, but the smaller bulb in terms of wattage is going to provide more current limiting, so there's more resistance going on. So I'll start out with that bulb. It's going to glow bright at first. When I power on the unit, you're going to see that bulb go bright, and it might stay bright for a little bit, but then it'll start dimming down, and that's what we want it to do, hence dim bulb tester, because ultimately we want to see the bulb filament glowing dim. We want to monitor the bulb filament to make sure that it's staying nice and steady wherever it rests at. Once it dims down, we want it to stay steady and not flicker or try to come up bright like something's trying to draw heavy current and go into failure mode, okay? So we're limiting that current, and we want to make sure it behaves itself. And if it stays steady for a while and, you know, it does okay, then I'll let it have a little bit more current. I might bring in another bulb or switch to a larger wattage bulb and allow it to have a little bit more current. So incrementally, I'll build up to the point where I'm going to allow it to have full current if it looks like it's behaving itself, and then go from there. Okay, so that's what I'm going to do to get started. Let me go ahead and do that. I could explain more details and all that, but I don't want to get too far into it. I think you kind of get the point with what I'm trying to explain here. So let me start by bringing in the 40 watt bulb there, and we're going to see it probably go pretty bright. And if everything is okay though, it should dim down a bit. Okay, so pardon me, I'm hitting the tripod and all that. So boom, there we go. And you see that it's dimming down, right? Right. And the level of luminance that you see in the bulb should stay there nice and steady. All right. It shouldn't be trying to get bright again or start kind of flickering and surging. It shouldn't be doing anything like that. So that's a fairly crude, if you will, compared to some instrumentation. That's a fairly crude diagnostic tool, but very effective one in monitoring the bulb filament. So there you go. So I'm going to monitor that for a little bit, and I'm going to come back after a few. I want to really keep it heavily current limited like I'm doing right now, being that this thing is known to have some problems and it's known to make some big scary noises. But so far so good. That's a good sign that it's not trying to surge or come up or anything like that. I'll eventually pull in another bulb, and then I'll come back, and I'll come back actually before I do that. I'll monitor it for a little bit. I'll come back, because at some point when this gets enough current, we should hear the protective relay click in. We should hear a little click showing that the protection relay is coming in, which is a good sign, and go from there. So I'll be right back. Okay, so I'm back. I've been monitoring this first bulb for about 10-15 minutes, right around there. Not a single hiccup. It's not trying to brighten up or flicker or surge, whatever. So that's a good sign. However, I haven't heard the protection relay come in yet, because obviously this thing is so starved of current. Yeah, without enough current, it can't function fully, okay? So the protection relay isn't going to come in other words. So let me go ahead and bring in another bulb and listen out and see if you hear the click. When I edit this video, if it sounds like the click is way too low in the background, I'll probably boost the sound a little bit in this one little area just so you can hear the click, hear the protection relay come in. But let me go ahead and bring in another bulb, and I'll stay real quiet. You probably heard that click. Okay, good. And the other bulb that I pulled in, the two bulbs now, nice, and yeah, they're very, very dim. So this thing is actually doing really well. I'm going to monitor it with these two bulbs pulled in right now, and just kind of see, you know, what we see now that it has a little bit more current. I'm going to keep doing that until I get to the point where I feel confident enough to take it off the current limiter, which, you know, I'll probably do at some point. I may not do it for a while, so I may, of course, keep it current limited still while I'm doing some basic testing. One thing that I do want to do, and I'm going to show it, is we're going to look at the back of the unit at the speaker terminals. I want to make sure that there isn't any DC voltage present that shouldn't be there. I'll talk a little bit more about that in a moment. But let me monitor these bulbs, make sure that it's going to behave itself. We heard the protection relay come in, a very good sign. So I'll be back in just a moment. Okay, so I've been monitoring everything on the current limiter. Not a single hiccup, that's good. So what I'm going to do now with the unit powered on, of course, is I'm going to check around back, check the speaker terminals, make sure we don't have any excessive DC voltage levels. We want to see as close to 0 volts as possible. In the real world, there's probably going to be, you know, some lower millivolts that we're going to see on the speaker terminals. Now, there isn't an adjustable DC adjustment, you know, any trimmer pots. There is, of course, bias trimmers to adjust the bias, but if there was any excessive DC that you know, fell outside of acceptable levels, then I'd have to go in and suss that out on the amplifier boards, on the circuit boards, and probably end up changing the differential pairs, the differential transistors, and checking some tolerances of some of the supporting components and all that to get everything in balance if there's a problem. But again, anything under like 100 millivolt-ish, right around there, is okay. We don't want to see things getting up into the hundreds of millivolts or whatever. You start getting DC levels, higher DC levels like that, you'll start heating up the voice coils of the speakers, and you know, things get too high, you'll burn out your speakers and all that stuff. Higher DC levels will produce distortion, you know, noise and all that. So because we had a problem with the speakers, according to the customer complaint, of, you know, loud crackle and pop and all that stuff, we want to, you know, rest assured or be assured that we don't have anything going on with high DC levels, and everything's looking good at the speaker terminals. So let me go ahead and get to that and set it on DC voltage here. Yeah, you can see the meter face. Let me go ahead and get in here, reach around back. All right. So on the left channel there, 42 millivolts. Let me switch it to millivolts. Yeah, 42.23, whatever millivolts. Let me check the right speaker. Woo! All right, let me check the right speaker. 35.2 millivolt. Yeah, that's fine. Nothing to lose sleep over. So that's looking good. It's not worth me going in there and trying to tweak it, get any lower than that, but that's totally acceptable. Some people obsess and, oh, I want it at 0, and that's great and everything, but in this situation, not going to happen. If it was excessively high, then yeah, I'd get with the customer and, you know, weigh the options there and you know, address it. So anyways, let me go ahead and start prepping things up to get a signal in it so we can look at the channels, both channels on the oscilloscope, and see what the heck is going on, if we have that pop, crackle, or any intermittent behavior, any jitteriness, anything that's wrong, and go from there. So you see over here I have the function generator, 1 kilohertz tone feeding in the auxiliary inputs. I am going to be checking all the inputs, and I'm going to be giving this thing a bit of a workout. But over here, of course, you see the oscilloscope. Okay. And what do you see there? Let me zoom in a little bit closer. You see a very clean and crisp, well-defined waveform. Okay. And actually, it's both channels, right and left, but they're stacked on top of each other. And you can see, being that they are stacked on top of each other, that they're nice and symmetrical. So here we have our, you know, let me switch it all the way over to the right. over to the left, right, left, all that. Okay, so you know, the yellow is the right, the blue is the left, and now they're stacked on top of each other, very symmetrical. Everything is looking good. So I've been monitoring this now for about 15-20 minutes, and I've been alternating the you know, the amplitude via the volume, you know, bringing up the volume and all that stuff, and not a single hiccup. I've messed around with some of the controls. Well, you just saw me manipulate the balance control, but you know, the volume control is doing well. There isn't any noise in the volume control. You know, I haven't ran the volume control all the way through its range yet, but you know, when I start power testing it, I'm gonna bring it up, see what this thing is putting out, see what it can do. You know, give it a bit of a workout. But all the other controls are looking pretty good overall. Yeah. Now I'm not going to run a square wave and start messing around with the tone controls via, you know, square wave and all that, but you get the point. So I'm just rotating the treble back and forth, our mid-range. This is just to demonstrate that there isn't any intermittent behavior or noise, crackle, nastiness in the controls, such as when the controls are really dirty. Now I don't know how good these controls were cleaned out when they were in the shop, but you know, I don't know if the tech did it to my specs, my level of multi-flush cleaning, really exercising the crap out of them, and future-proofing them a little bit better. I don't know if he went to that extent. I can't really say, but yeah, all the that's tone defeat and high and low filters. The push buttons don't seem to be producing any noise. Okay. Yeah, they seem pretty good. All the controls seem to be tiny bit of noise in the monitor switch here, but nothing to write home about. Not a big deal. Yeah, everything seems to be pretty decent as far as the controls. Not too bad. You know, whether or not the customer is still going to want me to go in and service the controls at depth the way that I do it, then, you know, him and I will talk about that or whatever. But so far, and again, I'm going to put this through some more rigorous testing and monitoring. I'm going to keep it on the scope for a while, probably over the course of a day or so. I'm going to leave it on the bench for a day or so, but I've got to get it out of the way. I'm not really ready at this point to get into the work. I'm only doing a quick evaluation, a down and dirty evaluation. That's what this video is all about. And then I'll set it aside for a little bit, talk with the customer, and then when I can get back to it after I shuffle around or juggle around some more equipment, then I'll get to it. But I'm really swamped with work. And I know the customer wasn't even expecting me to get to the evaluation this quick, but I just wanted to get it out of the way, start building a file. So I'll build a little file of what I've done thus far, set it aside with the unit, so when I get back to it, I'll have a file already started and go from there. So anyways, I'm going to be going into much more rigorous testing. Like I said, over the next day or so, I'm going to monitor it some more, run it through its paces, keep it on the scope at different volume levels. I want to put it through its paces to see if it's going to start misbehaving, if it's going to start exhibiting any noise in those channels. These are absolutely clean waveforms. So again, guys, I'm going to keep monitoring things, but before I conclude this video, let me see what this unit is putting out real quick. Okay, so I'm going to bring it up to clipping. Let me see here. We back it off until the clipping goes bye-bye. Right about, there looks pretty good. And we have about 140 watts per channel into the 8 ohm load that I have connected to this unit for power testing. And there you go. Oh, and by the way, this is a 120 watt per channel into 8 ohm receiver. I think I mentioned that in the beginning there. Okay, so I'm still monitoring the outputs, and you can see this time I don't have the channels stacked on top of each other. I have them, you know, separated there, the yellow trace, right channel, blue trace, left channel. Everything has remained completely stable, not a single hiccup. And, you know, again, based on the problem that the customer is describing, and, you know, the way that he described it was, you know, it's not an intermittent once in a while thing. And when it's going on, it's something that's really obvious. It's in your face, it's harsh, there's crackle, there's pop. You know, kind of scary noises there. So if there was anything like that going on, we would definitely see it on the scope display. It's not something that's, you know, going to be hidden way down on the noise floor somewhere. And you know, this is a problem that would be present. So no anomalous waveform activity whatsoever in the time that I've been monitoring things. And by the way, it's probably been about close to a few hours at least that I've been monitoring the scope display off and on. I mean, I'm not sitting here staring at it for a few hours, but, you know, I spend some time looking at it, move on to something else, kind of come back, look at it, and yeah, it's still stable as can be, is the point. So, great. And again, he said that, you know, when this is happening, which is, again, a persistent problem, that when they stomp on the floor and kind of rattle the speakers, that it seems to have an influence. Along those lines, I did ask the customer if, as this is going on, when he moves the speaker wires, is there any change? Or, you know, has he moved the speaker wires? And he told me he did, that he's moved the speaker wires around where they enter the back of the speakers, of course, and that doesn't really seem to have as much of an impact as, again, stomping on the floor and kind of rattling the internals of the speakers. So he seems to think it's some kind of an internal connection issue, which it very well may be. So time will tell when I start checking out the speakers themselves. When I get around to that, fine. I'm not going to do that today. I just wanted to check the you know, the amp, the receiver, and see if there's something going on. I wanted to isolate this from the speakers and monitor things, and yeah, everything again is fine. Will something change with time? Well, I don't know. I've been monitoring things off and on, like I said, at least for a few hours, messing around with controls, doing this, doing that, and everything's pretty much the same, nice and stable. And, you know, you guys that are watching this video have observed that too. So anyways, one thing that I will bring up as far as a problem, an issue that I did discover, which is not an issue that has anything to do with the signs and symptoms that the customer is describing, involves the speaker select switch. So right now I have terminals, you know, the A terminals, in other words, selected. Okay, there's the A terminals, B terminals, and the C terminals. There's also A plus B, but whatever, A, B, and C. And I have the A terminal selected, which is what I have my load hooked up to right now, and, you know, that's what you're looking at. Now, when I switch the speaker select to off, well, we should lose that signal. Not only do we not lose it, but there's an increase in amplitude. Okay, back to A, and that's what I'm hooked up to, so that's all well and good. Now let me move it over to B, and I don't have anything hooked up to the B terminals, obviously. Same thing. Signal's still there, and there's an increase in amplitude. Switch it over to C. Okay, there you go. But you'll notice, although that's unusual, we shouldn't have a signal on terminals that we're not hooked up to. Okay, I don't have, you know, my load hooked up. I'm not monitoring with the oscilloscope probes on those terminals. I'm monitoring the A terminals. Let me switch back to A. So anyways, you notice though, regardless of that issue going on, there is no distortion, no static, crackle, pop. anything like that that the customer is describing. So when I get around to sussing out this unit here and going deeper, I am going to have to take a look at the speaker select switch, check the switch, the wiring. I don't know if someone was in there screwing around with the wiring on the speaker select switch, whatever the case, but well, whatever. I'll check that out when the time comes. I'll cross that bridge, but that's not what's causing the problem by any means based on what the customer is describing. But I did want to point it out nonetheless. It is something that I'm going to look into. So anyways, and as far as inputs go, everything seems to be doing okay there. Let me hook up an antenna to this real quick. Okay, so let me switch on over to FM. See what we got. So yeah, I'm actually tuned onto a station right there. And I'm not going to pan the camera down because it's just too much of a hassle to move things around. I'm kind of pinned in here and I got stuff in the way. So, but the stereo light is on. We have multiplex. We're pulling in a station there. Let me just tune around a little bit. And let me see. Here's another station coming in. A little bit faint, but let's see. Okay, there's another station there. We have our stereo light. Let me tune around some more. Okay, there's another station there. Let me lock onto it. Yeah. All right. Okay, another station. So the point is that it's pulling in stations nicely. Our stereo light is locking in good. So we have our multiplex. Yeah, it seems to be pretty sensitive and doing okay. So yeah, there you go. Okay, and what we're looking at there is, it's a little bouncy because we're looking at a piece of test vinyl playing a 1 kilohertz tone. So the phono inputs are working is the point. All right, so that about wraps it up. I learned a lot as far as what I needed to know based on the customer complaint, evaluating that customer complaint, and determining whether or not we had good clean signal being outputted, and we do. Everything looks good, and also too, as far as output power, we're at right about 140 watts per channel into my 8 ohm load. Everything was looking good there. All the controls seemed to be functioning just fine. They were relatively clean. They weren't producing a lot of noise or anything like that. Other than that issue going on with the speaker select switch, which I'll look into that at a later date when I start digging in once again, as I already said. We don't have any excessive DC voltage at the speaker terminals. We're looking good there. As far as the bias is concerned, when I start getting into things in a little bit more detail once again, I'll deal with looking at the bias, setting the bias and all that. I could tell based on the way this unit is behaving / performing that the bias is in the ballpark, that it's not grossly over biased or grossly under biased or anything like that. I'm sure it's in the general ballpark once again. But otherwise, this thing is actually performing pretty darn good. So again, I think we're dealing with an issue with the speakers, which I'll get into that again at a later date. I'm going to shelve this thing for now, get on with some other work, and really that's about it. So guys, as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.